This video introduces an innovative technology to produce ceramic multi-layers, which uses a new concept and improves the state of the art. Using the Ceraprint technology reduces prototyping time and costs with minimal investment. The total time of the video is approximately 10 minutes. If you would like to receive more detail regarding the technical essentials, please ask for the second video. The Ceraprinter is based on a patented technology. Because the present version of the Ceraprinter is the third one, the technology has been refined to include many improvements based on practical experience. The main part of the Ceraprinter consists of carriers. At the top of carrier Y, the layers can be positioned for dispensing conductive paste. At the bottom of carrier Y, a vacuum holder exists for punching holes, the vias. The positioning resolution of the carrier is 10 micron, which is 10 times smaller than the smallest conductive pattern on the layer. Carrier X contains two tools. The first tool is a dispensing unit, which includes integrated proximity measurement. The second tool is a punching unit, which includes the provisions to remove the punch waste. First, we will take a look at the punching system. The punch stamp has a diameter of 250 micron and is lifted from beneath. The punch waste is removed through the punch saddle by means of a vacuum and is removed into a container. The paste dispenser is located above the punch device. The dispensing opening is 75 micron and barely visible. The distance between the ceramic layer and the dispenser is controlled by air pressure. This is accomplished by using two sensors which measure the air pressure every 1 millisecond and calculate and control distances. The accuracy is approaching 1 micron. Here we see the paste running out of the dispenser. The dispenser motor and the carrier for multilayers are synchronized in order to control the amount of paste. Through a specially designed software, the Ceraprinter can compensate for the compressibility of the paste, which can result from a few percentage of air in the paste. Due to this synchronization, it is possible to control the paste needle in such a way that there is no paste congestion and ensures a finite end to the paste flow. A good example of the potential and possibilities of the synchronization of the motors is the pattern of two twisted spirals. The two spirals are twisted into each other with a distance of 0.35 mm in between. This pattern can be made in seconds. The punching tools can be freely moved along the complete ceramic layer. Only at the very end, where the vacuum holds the layer, it is not possible to punch. When lifting of the dispenser is done simultaneously with punching, it requires no extra time. This is also a guarantee that the via is exactly positioned between the lines of two layers. This was not possible when punching and dispensing were done on separate machines. We will demonstrate the layer handling with numbered sheets of paper. The layer is put manually on the carrier. Once the position of material is fixed with a vacuum, it will be used as a reference point for the process. The carrier is stopped in a position to punch a via. The dispenser is not used yet. The first layer is now moved from the punching position at the bottom side of the carrier to the dispensing position at the top side of the carrier. Then its position will be fixed with a vacuum. Before placing the next layer, the last layer has to be heated to dry the paste. It will take approximately 1 minute until the paste is pre-dried and ready to continue the process. The final heating will be done in an oven after the complete multi-layer is pressed. Since punching and dispensing is done with the same carrier, it is important that the XY position can be reproduced. The absolute positioning fault is irrelevant. The ceramic layers are not porous. Therefore, the vacuum only holds the bottom layer, which means that the other layers must be fixed with glue. This step occurs after the pre-drying process. When cutting the final multi-layer, this glue will also be cut away. The 4 layers of this example are now layered and can be taken out of the Ceraprinter. The multi-layers are now ready to be pressed and heated. In this sequence we see the dispensing unit. Because we have full freedom of movement, every pattern can be produced like small and thick lines as well as conductive areas. Prior to these patterns, all vias that are not a beginning or an end of line will be filled with paste. When the lines are drawn, all vias are punched and the cavities can be cut. Sometimes it is necessary to use different types of paste for one multilayer. In this case, it is very easy to change the dispenser. Changing the dispenser only takes a few seconds. A connector can be used to detect if the appropriate paste is being used. Using the connector prevents different pastes from being mixed up. To show the accuracy of the Ceraprinter, 21 lines are drawn in parallel. The lines are drawn at a distance of 0.3 mm from each other. For quality assurance and administrative reasons, it is also possible to mark a multilayer with a production date and time. Here we see the end result of the 21 lines on ceramic material. This is a cavity. A cavity is produced with the punching tool. A few affixments will hold the waste material until it has been taken out. In this video, we have provided a short introduction of the Ceraprinter to stimulate a better understanding of the possibilities and applications of this technology. The Ceraprinter's innovative approach for preparing a ceramic multilayer reduces time and costs for the production of small batches and prototypes.